I'm Jennifer Bell, and I'm a product engineer, geographer, cartographer. We wear many different hats on our team. We are on the Living Atlas team. I've been at Esri for about 4 years, and I love smart mapping. Our team works directly with the developers of smart mapping, and then we work a lot with our users. So we are the users too on our team, and we're constantly making maps, especially web maps in ArcGIS Online, and we're using smart mapping to enhance the map, to explore your data, to create maps that can enact change. And there's a few things that you can do just a few simple clicks away to make your maps even better, to make them stand out and shine. What I really like is using smart mapping to make my data tell me secrets. You know, the secrets about the world around me that you might not have seen mapping a traditional way of mapping. So we're going to go into that today, and this is my colleague.
Hi, I'm Diana Lavery. I'm also a product engineer on the Living Atlas team, and I pretty much work exclusively on within ArcGIS Online, creating web maps and using smart mapping every day. So I'm excited to show you guys some little tips and tricks that I use.
So today we're going to talk about what smart mapping is. And I asked earlier to raise your hand if you knew what smart mapping was, and I think I only saw a few hands in the crowd. So this is really great. You're in the right place. We're going to first introduce what it is, where to find it, how to use it. And then within smart mapping, there are different rendering options, or drawing styles is what we like to call it, ways to visualize your data on the map. And then we'll talk about, throughout the demo, it's less death by PowerPoint, more life by demo. So we're going to go into the software, and I have 16 slides. They're going to be available later. You're here to see an actual demo and how to use it. So we can show the slides later, but I would like to go in and just start with what smart mapping is and showing you guys many different, hopefully fun and exciting examples that you can relate to. And feel free to call out, that map's boring or doesn't relate to what I do. So I want to see a map of utilities, or I want to see a map of healthcare, and we'll find a map and show you how you can smart map it. So quickly, what is smart mapping, if you want to go over that?
Sure. It's basically a starting place. It looks at your data and it tries the best that it knows how to tell you, hey, your data has an average. It has a maximum value. It has a minimum value. It has a distribution to it. Here are the standard deviations, and I'm going to use that and show you the color variation based on those things. So when you go to the change style, a lot of times you'll see this histogram with your color ramp, and that X bar, you can hover over it, which I'll do in a minute, and show you what your average is in your data. And that's usually where it will center that above and below. Or if you're doing a single color ramp, it'll put the dark and light at that one standard deviation on both sides of that. Those are the top and bottom most break in that example right there. The max and min are the ones at the very top of the color ramp and the very bottom. And it's a great starting place. And it's also a way that even if you don't know anything about this particular field of your table, it's still making a statistically sound map right out of the gates.
That sounds pretty smart. Smart defaults is what we like to call it. Looking at your data. So you bring in your data set into ArcGIS Online, and with smart mapping, it automatically looks at the distribution of your data. It sets the breaks in the optimal location, the standard deviation above and below the average. This is the final map, and this map shows colleges and universities around the U.S., and it's using clustering. it's showing in this area in Chicago, universities are more common, whereas in this area in purple, cosmetology schools are more common along the Mississippi. So this is how we build a map like this. So I'm sure many of you are familiar with a simple map that has your pure location, your XY coordinates. Where are all the colleges? This is great, and there are lots of things you can do within smart mapping for a simple map like this. It can be very effective, and we can also take it to the next step. So here under your layer, you add your layer to ArcGIS Online, you bring it into your map viewer, you go to change style. It's that little icon below your layer name. So this is where all the smart mapping magic happens. So go into there, and there's two simple steps. The first one is to add your attribute, and the second one is to choose the drawing style. And by attribute, it's kind of like an Excel table. You've got different columns. Each of these schools has information about it. The name, the address, the city. Each of these columns is one attribute. So what I'm interested in is the attribute called industry. So that's the type of college that it is. Before I go into that, though, there are some things you can do to enhance your pure point location maps. Heat mapping is one option. With the last release of ArcGIS Online a month ago, we originally had about 4 heat mapping ramps. We have a designer on our team who specializes in color. A lot of these color ramps are colorblind friendly. Some of them are Cindy Brewer inspired. But you can choose different modern looking heat maps, set how much of the high value you want to see in the map, and you can change the area of influence from smaller to larger. So this is a really fun way to visualize your data. And I would recommend possibly removing the transparency to get more of that solid effect. So it all depends on what you're mapping. We have some pictures, so I'm going to wait. All right. So let's go into smart mapping. Choose the attribute. I'll select the industry attribute. So what kind of college is this? Now, another reason why we call it smart mapping is I chose this attribute. It's a string field. And so smart mapping knows, okay, it's a string. There's different categories. I'm going to recommend the types, unique symbols, drawing style. So that's a very intelligent feature. We can go in to the drawing style and change the individual symbol. There's lots of symbols that you can choose from. I think state government just released a lot of new symbols. Got hospital, library, there's general infrastructure. The firefly is actually a really fun one that John Nelson created, and they're just really bright firefly symbols that stand out in your map. And we can also add a custom image by copying and pasting a URL of a JPEG or PNG that's hosted online. And I've done so, and it's saved in my custom images section. So I made some custom images in Illustrator, and you can change the size. So now you have the colleges and universities showing. It's kind of difficult with all these points to really see the pattern in your data when you've got a lot of points on top of each other. So there's clustering, which is released last year. And here the points cluster together. You can have less clustering or more clustering. It depends on the data. In this case, I would choose the less clustering. And now you can see in this cluster in Dallas, there's 134 colleges. The most common type is a university. So it's really impactful for your point data sets to do the type style, location, or heat mapping style. So I'll turn it over to Diana to show another example of how to take your points to the next step.
Yeah, what we have here is a points data set that is depicting hospitals. These are hospitals that have a Medicare per patient spending score. And I took this straight from the Hospital Compare site on Center for Medicare Services.gov, and they've given us a gift. They've said that every hospital has this score. A score of 1 means that you spend the national average. Your hospital spends the national average per patient on these common procedures. Anything above that is higher, anything below that is lower. So if you have a score of 1.05, you're spending 5% more than the national average. So when I first brought that in, it looked like this. I've actually filtered it just for the state of Texas. It's a national data set. And I want to map that score that I just described. First thing is, it thinks that it's a text string because some of them have the value of not available. That's what's written in that score. This would be really great if I wanted to show a categorical type of attribute, such as teaching hospital or not, for-profit or not. You could do those in different colors, the way that Jen did with the schools, the school types. But I just want to show this as a number, and it's thinking that it's a string. So I'm going to scroll all the way down to create a new expression. And using Arcade here, we can call this expression numeric score. The globals that you see here are all my fields, and then this functions tab are all of your favorite functions from Excel, from other software programs that you might be familiar with. There's numeric and string and Boolean, different types of functions in here. So the function that I'm going to use is just called number. And my field is that score type. Test for syntax errors, there are none. It thinks that it's a number. Perfect. Now, it's automatically giving me options that are appropriate for a numeric type of value. I'm going to go down here to counts and amounts color. High to low is the default. It's a monochromatic color, and it's unclassed, meaning it's just a continuous color ramp. It lets the data breathe a little bit. If I wanted to classify the traditional way, you could do that, but now we've got the opportunity where we've got all different shades of blue, so we can show as much variation as is in the data. It tells me that the average of this is 1.04. Interesting. I thought the average was 1. Well, it is in the national level, but somehow with just the Texas points, we've only got about 400 now out of that original 5,000. Now the average is 1.04. And the standard deviations are, one standard deviation above and below is right here. What I would recommend when you have a score such as this or a ratio where you have a clear reference that 1 is meaningful, use above and below instead of that high to low. And I know that 1 is meaningful, not 1.04, so I can change that. And the standard deviations are useful, but really, I know, because I know this data, that if you have a ratio of 0.6 or better, say, then you're doing something really, really well. People are going to come to you and say, hey, what are you doing? You're like the top, X%. That's amazing. And you might get some kind of recognition from the Center for Medicare and Medicaid Services. Likewise, if you are 1.5 or higher, say, you're going to be under review. That's like a hard line cutoff. I don't care what the standard deviation is necessarily. I know that there's some meaningful policy that takes place at 1.5. So I can make that the darkest blue, and everything above that is going to be that dark blue. So using the starting place from the smart mapping, but then also using your subject matter knowledge of this data set is a great way to do that. So here, if say I want to make this map, I'll just do 0.1 above and below. And to make it look a little different, I can change it to a diamond. And while I'm at it, I'll take off the outlines and see what that looks like. And let's change this to something really bright. Since I'm using a dark base map, I'm going to look for one that has a dark center to it, so that everything that's right at the average, that's not important to us. That's not what we're mapping with this above and below style. The above and below is really outlier driven, so that's what we want to light up. If I'm using a light base map, I'll check for one that has this light center to it. But I want the dark base map. And like I said, hospitals that are spending way more than the national average, they're doing something a little inefficient possibly, whereas ones right below are doing something really great. So why don't I make those ones the green ones, and the ones that are above, something's a little off. So I want to really highlight those and make those pink. I can invert this color ramp, and now I've symbolized this, starting with the smart mapping defaults, but then adding my own knowledge of the on-the-ground information that I have if I'm working with this data on a daily basis.
Yeah, I really like that. With smart mapping, if you have a dark gray base map, it's going to recommend the ramps that are best for that color. If you have a light gray base map, smart mapping sees that and recommends the light gray ramps that are best for that base map.
Does that expression column appear in your pop-up?
Yes.
No.
You can add expressions in your pop-up. Yeah.
Oh, okay. Well,
yeah, sure.
I can do that. What I've done is creating a custom attribute display and added this expression from existing expressions that I've had before. Right here, I can add the number will show up whether it's text or numeric, but one that I added earlier.
So it remembers your existing expressions that you've written in the particular web map, so that it saves you time. You can just click on it and it appears. You don't have to rewrite it or copy and paste.
Mm-hmm. So here I just wanted it to be a conditional text string, one that says above, one that says below, or no different than. So what this looks like here is this hospital has a spending ratio of score. This is still that text score. And then now that I've added that expression, I see it here, and I can add it within the text of my pop-up. So here it'll say above, below, or no different than the national average. And you can bold this, you can center or whatever you'd like to this, but what this looks like here, if it's a pink one, it'll say 1.03, that's above. This one here, 0.85, below. Or this one right here, covenant, it's a ratio of 1, no different than. All right, I think Jen has another example with lines.
Yeah, so taking it back to the simple example, because this is more of an intro to smart mapping, but we're also showing powerful maps that you can do very simply as well. So this is a map of roads in Florida, highways, primary, secondary roads. And right now it has the default base map that I'm sure you've all seen. The base map colors are great, but it's kind of competing with the color of my layer. There's lots of vector tile-based maps that you can choose from to really make your maps stand out. There's the newspaper-based map, the Nova base map. There's the World Firefly imagery base map that works well with the firefly symbols. And the human geography base map is really good because it really makes your layers stand out. In this case, I'll choose the dark base map. So now the colors are really popping. And I want the thickness of the road to represent how many cars are driving on it, the annual average daily traffic. And that is an attribute in this layer in my data set. So when I select the attribute, it automatically thickens the road based on the value. So, in between Tampa and Orlando, we've got a lot of people riding on that street per day versus some of the other minor streets, which are a lot lower and thinner. If we want, we can also, with smart mapping, add more than one attribute. So here it says add attribute. So I'm interested in seeing not only the thickness of the line to represent the annual average daily traffic, but also the district that it's in. So who owns that road? So now smart mapping sees what you inputted, recommends what drawing style will work with that. So we're exploring our data. We're seeing, oh, there's this orange road, this orange highway that goes down that is going through Orlando but isn't in Orlando's district. But we're also seeing the number of cars on that road per day. Now you can go in through options and change the individual colors of the line, or you can choose from a variety of base map or color ramps. These, as of the last release, the last few are new. These are sequential. So these are good for your sequential data sets like age or education level. In this case, district is not a very sequential thing. And this is the final map after I changed some of the colors. It's using the human geography base map, and it's very soft, but then you're also getting a lot of data just with two attributes. I'll show another one. So this one is white collar versus blue collar. Jim and Deb Fallows asked us to make a map. They were flying around the U.S. and exploring cities and seeing, where are the manufacturing jobs, where are the tech jobs. And so we have a data set that has the number of, it's the number of people working in those sectors. And so this is the original data set. It's a county boundary. And within here, we've got information on how many people are in the manufacturing industry in that county and how many are in the tech industry. So when you go into smart mapping, I'll choose manufacturing and I'll choose tech. All right. So it's looking at the data. I've put in two numeric values. In the previous example, I had the district, and then I had, which is a string, and then I had the number. So it suggested the types. These are two numeric values, the number of people in each industry. So it's recommending color and size. We can also do compare A to B, a ratio map. We can do a predominance map. So this is like an election map, who won. So it's looking at the two columns and returning the column with the higher value. In this case, I chose predominant category and size. And with blue collar, I'm going to color it blue. And then with white collar, I make it white. And you can add hex values here and set the transparency. What I like to do is remove the polygons. Sometimes you need them, sometimes you don't. And we can manipulate the size of the symbol. So notice everything that I do on the side automatically happens in your map. This is a really great feature. You don't have to change it, hit apply, wait for the changes. You're seeing it automatically. You're not punished for trying something different. That's the adjust size range automatically, or we can set a hard size that maintains throughout the different scales. So that's predominant category. Something that we released last year is the ability to add, before it was only 5, now we can add up to 10 different columns of data and it'll tell you who won. So if it was an election map and it was 10 people going against each other, it'll show you who won in that area. And so when we add agriculture, which is now in blue, you see agriculture is very popular in the center of the US. Manufacturing is very popular here. And tech industries are popular in the cities, which makes sense. Do you want to give another example?
Yeah. How many of you ever work with date fields? Cool. Here we've got some buildings in Rotterdam. One of the attributes we have here is year built. How would smart mapping handle a date field? Let's see. In my styles, I'm picking year built as the attribute I want to display, and I see it picks up the fact that this is a date field. So I see these little time icons with all of these style options that I have. I'll pick the continuous timeline color one, and the themes now adjust for dates. We're going to do this before to after one. And again, we get this histogram. It tells us the average year built of these buildings. But again, I'm curious in a critical value, and that value is 1940. World War II, above World War II, newer, or below. And so I'm going to make that my center instead of the default average, which is close, but this date is a little bit more meaningful in this data set. So again, we can adjust these ramps, these other dates as well. We get the max, we get the min, and that's one way to map a date field. Another would be year built using what's called age. We click on options here. It automatically says, hey, you want the age up until today, right? Well, no, maybe we're looking just at this past quarter or this past year. You can adjust that, but we'll stick with today for now. And the oldest building in our data is 147 years old. The newest one is 10 years old. And the average is 69 years old. And again, we get that one standard deviation above and below. We can change the color ramp to anything that looks great on our base map that we've selected. Here we're using imagery. And we'll click OK. And now our legend is age in years, using that year built field of these buildings. So that's just one way that you can use smart mapping even with date fields, which are generally hard to work with in a lot of situations. Smart mapping, we've really built a lot of intelligence into the suggestions and the map styles that it recommends to you.
It's neat to see some of those buildings are over 100 years old. Mm-hmm. And then in the original map, there's that group of yellow buildings that were built during World War II. A lot of the buildings were bombed. They had to rebuild during those years. So it's interesting to see that in the map. Mm-hmm. Other ways you can use this date field with your smart mapping is you've got a bunch of streets in your city and they've been inspected and you want to see which ones haven't been inspected in a while. Or you've got a bunch of parcels and you want to see who's late on their property taxes. You know, how many days has it been since they last paid? There's lots of ways you can use this. I saw a question over there.
Yeah, just about the date. Do you have to enable the date field before or does it automatically?
You have to enable the date field before. So the question is, do you have to enable the date field for it to recognize it? And yes, just like how an attribute can be a string or a double or an int or a float, an attribute can also be considered a date. And to do this, you can go into your layers item page and set the column as a date field. And you can also do it in desktop when you're creating your data, set that new field as a date.
Can you change the date format?
Oh, can you change the date format in online?
That's a good question.
Day, month, year.
Right. So the question is, can you change the date format? So day, month, year instead of month, day. Yeah.
Yeah, I know you can in desktop. I have personally never done it in online.
Yeah, we'll have to take a look after the session to see. That's a good question. All right. I will show a similar example with arcade expressions and your line data set. So this is energy pipelines in Indiana. And I'm interested in creating a map like this that shows the type of material of the map, of the data, of the line, and the width of the pipeline. So when I add the pipeline diameter in inches, it's a string. So just as Diana showed earlier, I'll quickly go into the expression, and you can type in number, parentheses, and select that attribute that you're interested in, and it automatically converts it to a number. So now you can map this. The beautiful thing with arcade expressions is a lot of times we don't own the data that we're working with. You know, I download the parcel data set from my city. It's got the wrong format and I need to convert it, and I need to contact the person at the city and ask them to change it. Or they give me the counts, but I want to find the rate. You know, so with arcade expressions, it is very powerful, especially when you're not working with your own data and you don't feel like manipulating your own data even. And then we can add the type of material. And so very quickly, just a few simple clicks, and the original map of the line location is now made a lot more powerful. There's a lot more information, and we see the type of material as well as the diameter in the map.
Yeah, you can actually combine all these different styles that we have showed up till now. Earlier, Jen showed both clustering and predominance, but you can do clustering and predominance in one map. This is going to be crazy. So here we've got predominance of police incidents. Here's the type of incident shown in the color. So at this point, the type of crime here is theft, and you can see we've got 125 coincident points right there. That is a lot. And just looking at these, there's just way too many points for anyone to make sense of these. But we really do want to show the type of crime, or the type of police incident, rather. That's valuable information. So what I did here with this layer is I just clicked this cluster points. Because predominance was already set on the original layer, it's going to keep that predominance setting and give me, in this cluster, it represents over 700 incidents, and the predominant value of that type is theft. And if we clean up this pop-up like I did in this one, you get a really nice looking information product where we're using two different mapping styles in one, not just two attributes like Jen was showing a few examples ago with the lines and materials, but here we're actually using predominance. So we're saying, okay, who's the winner in all of the incidents at this location, but then also how many are there. And the clusters, what's great about them is that they're scale intelligent. So as I zoom in more and more, the clusters adjust or zoom out.
So how do we modify the pop-up in the automatically generated pop-up?
Great question. So let me get back to that first layer, the unclustered one. There's so many points, it's going to take a second to draw here. Okay, so first I'll enable the clustering. That looks pretty good. Here we'll configure the clustering pop-up. And it's just like the same way as before. The default will give you the name of your attribute field. And here it looks kind of computery. We don't really want that. So we want it to say the predominant value of the police incident.
Like the most common type
yeah,
of crime
exactly.
in this area is robbery.
Mm-hmm. The most common type of police incident within this cluster. We don't need that part in bold. And then this is the expression that is automatically generated with that clustering. So I'll leave that alone. Click OK. And here we are. If we keep on zooming in, eventually we do get to that original data with our original pop-up.
Yeah. Looks like some of them are stacked on top, like the same location.
Yeah, so yeah, here we go. So this one is just one original feature. And so that will take the pop-up that you've created beforehand, not in that clustering pop-up environment. Great question.
So just to show you some other examples, not going to build them, but to give you some ideas of how you can use smart mapping. This one, the data set had total population and population over 18, but I'm interested in where the youth population live in Dallas. So I create an arcade expression that's a simple mathematical function. It's total population minus people 18 and over. That gives us the people 17 and under. And so right now it's using counts and amount size. And so it can be very complex, or we can do something very simple like this. This is a map that I like to call the broccoli map. That's what we call it on my team, but it's a change in forest area over time. So, for example, China had a 33% gain in forest area, whereas here in Africa and Sudan, there was a 37% loss in forest area. So usually when we hear about the deforestation story, it's usually the negative side, but we wanted to create a map that shows where countries are doing a great job of planting trees. And so this one it uses two expressions. Was there a loss or a gain? So I created a variable of change, 2015 acres versus 1990. And if the change, that variable, was greater than 0, give it a category of gain. If it's less than 0, give it a category of loss. So that's the first attribute. The second attribute is the change. So when you do one number minus another number, when there's a decrease, it's going to be a negative value. However, I want to use the absolute function, the absolute value of the negative, to make it a positive value, so that the size of the symbol is large, whether it's a large negative or a large positive. And then I changed the symbol with the URL to an image that I created and hosted. But I could also pick one of the many symbols available. Okay, so this is a new drawing style, and it is called the relationship drawing style. And in this map, it is showing, I'll show the final app to explain it. City of LA has a street data set, and they drove every street and they monitored. Some streets have sofas and mattresses and large, bulky items on them, and some of them have more loose litter, like fast food, your trash, your wrappers, your bottles. And so in the blue areas, it's more likely it's primarily loose litter, and in the orange areas, it's primarily large, bulky items. And so you can do a relationship map by putting in the two attributes, loose litter and bulky items. The size, you can also do a third one, but you don't have to, but the size is the street score. And you go into relationship drawing style, and you can set the focus on high values, where both values are low. It depends on what you're interested in. This is also known as the bivariate choropleth map. And there's lots of ramps to choose from. So maybe red and blue make purple, so that might be a little bit more intuitive for someone to understand. And then you can also set the transparency. So I decided to set the transparency on the streets with little trash. So I went in to the legend area and set the transparency here on this value at 50%. So you can change the individual colors of the ramp as well. Another way to set the transparency on a value that you can do with any style of smart mapping is go to the set the transparency from an attribute. You can choose any of the attributes. You can write a new expression. In this case, it would be for the street score. And here you can see, you can make the high values solid. The low values can be up to 100% transparent. So you notice that it's showing you how transparent it's going to look on the map. So now those disappeared because I made them 100. So that's one little trick to really make your maps, look more modern, takes them to the next step, is using transparency to de-emphasize what's not as important and to really emphasize the areas of importance where you want your viewer to look. In this case, the orange and the blue areas. So, would you like to share another relationship drawing style, or?
Yeah, there's a few in the Living Atlas, actually. This one's one of my favorites.
Oh, yeah.
This is using the relationship style with polygons. This is from the county health rankings data that was put into the Living Atlas recently. Basically, where smokers are really high is in blue, where drinkers are really high is in orange, and counties that are really high in both are in brown. What's fascinating to me as someone on the policy maps team at Esri is that you can see some state outlines here while we're actually mapping counties. So we don't have state boundaries here, but yet I'm still seeing Pennsylvania, and I'm still seeing Indiana and Missouri, and I'm definitely seeing this Utah-Nevada boundary right here, because in Nevada, they've got really, really low cigarette taxes. They've got really liberal drinking liquor licensing laws. And then in Utah, they've got very, very strict liquor licensing laws. Similarly, in Pennsylvania versus New York. And that's why you can see this kind of state policy story really popping, even though we're doing a relationship mapping style using the polygons at the county level, we're still seeing a lot of states. So this is just one of my all-time favorite maps. It was added very recently when this relationship style came out, and it's available in the Living Atlas for you to use. If you're signed in, you can even share it just like you can with any web map in the Living Atlas. You can tweet it, you can embed it in your own website and your organization's materials, or if you're writing a newspaper, like a news article online, these web maps are designed to be embedded for web materials. So you can embed it in your website. You get the HTML code to do so, and you can actually configure it the way you like as well. Just like any web map that's available on the Living Atlas. It's shared publicly. Yes?
Is there a way that we can find the some description of what's happening behind the scenes? So for instance, with heat maps, a lot of the scientific community, when they're zooming in and out, they're freaked out because they're like, well, what's happening? How are you making your calculations? What are the regressions here? They just don't want to see the visualization, but also trust the results of the data. So if there's anything that metadata or something like that that can be seen there.
Yeah. So with this one, you can go into it and see actually what the breaks are, what is classified as high, medium, and low here. There are different methods to do those breaks.
Sorry, I'm talking more about the actual output, so people are not necessarily going into the change of style to know how you did it, but more on the, if it were to be a web app as opposed to a web map, how do they see that?
Right. So so the question is, you were doing all these really great smart mapping styles like heat map, but then someone sees the heat map and they might get scared. Why does it look so crazy in my area? You can create your web app and write the documentation for it describing why, and you can check out the ArcGIS for Developers site. All of the smart mapping behind the scenes action is explained in this site. So it's something to look into after. That's a good question. So we are almost out of time before questions, but if you go to arcgis.com and you search how to smart map, there's lots of apps that are available that show you how to do relationship, heat maps, color and size, time, predominance, arcade. There's lots of resources out there, a lot of them showing the examples that we showed you today. So this is the first step. I would start with this one, how to smart map. And it takes you through, here's the place where you click to change the style. Now you choose an attribute. You select one of the many drawing styles. And it just takes you through an example. It has GIFs that show you how to work with smart mapping. So we'd like to thank you for your time and coming here today. And we have 15 minutes for questions, so you're free to go, you're free to stay. We'd love to hear your questions and even pull up a map that you're interested in us demoing live about your interests. Yeah, thank you.
Yes, and feel free to provide feedback in the events app as well, and we would love to hear your thoughts. Question?
For both the building map and then the street map, did your attribute table have to have polygons in it that were tied to that building location, that information, the dates? Or how did it know the actual building location and just the polygon location?
Repeat the question.
Yeah, so she's asking how were the records in the table linked to the polygons themselves?
Yeah, I'm assuming you had to have a square footage or something for that building tied to that date so it would know that and highlight that space on it. Mm-hmm. Or is that inferred from the base map? Or?
So when you're creating your layer, for example, for the buildings layer, it's parcel data or it's a building footprint, and that's the original polygon layer, and that's its own entity. One building is its own unit, and it's going to have its own data connected to that building. So it's a row in your data. So building 1 is going to have all these attributes, building 2, and it's a polygon data set that either you got from the city or you created yourself. And same with the line data sets.
Yeah, I mean, these could be cities, and the date could be the year that the city incorporated as a city, and that would also be a polygon as well. And the base map here is just the imagery behind it so that you see the buildings, since we're doing buildings in this case. But it could be any polygon or point or line that has some kind of date associated with it. It's just another type of field.
Does that answer your question? It's a different geometry types for each data. Line, point, polygon.
Yeah, but that's something you have to find, elsewhere and bring it into here.
Yes, so we're adding our layers.
Imagery behind it and have convert.
Yeah, so we're adding our layers. You sign in to your ArcGIS Online account.
I'm
You
not
can
signed in, that's why.
add layers from other people. You can add your layers from desktop, your content, from the Living Atlas. You can create a map note. So with the map notes, you can actually draw the polygon and create the data yourself.
Yeah, we didn't go over how to add data, but yesterday I did a session where I was geocoding from an Excel table where I just had raw addresses and brought it in and geocoded those addresses so that that's where it shows up on the map.
Yeah, you just drag and drop the CSV into the map view, and then it says, how would you like to geocode this? What field is related to the geography? Great question. So what are you guys mapping these days? Anything you'd like for us to pull up? What industry? Is anyone in local government? Okay, one. Federal, education, healthcare, tech. So where are you guys from?
Civil engineering in Houston.
Civil engineering. Okay, great. Right, so many different industries.
Cool.
So I have another question.
Yeah.
If I have multiple layers with different times, they're all the same time, so everything is, uniform time locator. They all mean something different and associated with that base layer. If I time enable every single layer, is there a way to compress it so everything moves at the same time? And you can see that trend in time for the different layers. So use symbology for the different layers to represent that time with that attribute. But I want to see all of the time enabled frameworks.
So the question was, layers, first fields can have a time component to them, and then layers can, but certainly the entire map can also have a time association with it. So how can we make our map time dependent or time intelligent? I know there is a way to, I just don't know it myself. Have you ever done time-enabled maps?
For the time-enabled maps, I usually add a time slider at the bottom, and then the user can click play and then see the map change over time. So instead of having many different layers to show this, you can have it in one layer.
So I usually do it by going to the ... and say enable time.
Yep.
But that's tied to that one specific layer, right? So
Right.
if I have multiple layers with different time attributes.
I would then append the layers together into one layer.
So consolidate.
Yeah. But I'd love for you to come up and we can log in and take a look at what you're working with. Yeah.
Or choose the one that has the largest time range and let that one be the one that is tied to the time slider at the bottom, and that way the other layers will show up throughout that, within that larger time range. Any last questions? All right, well, thank you guys so much.
you.
And once again, feel free to leave us some comments in the events app.
Yeah, we'll be here for the next 6 minutes or so if you want to come up. Thank you.
Thanks.